So we are looking at comparing linear and exponential growths. And I have Connor's holding up here something to keep in mind as we're doing this, that linear has the arithmetic sequence a sub n equals a sub 1 plus n minus 1 times d, or y equals mx plus b, okay, because these are linear. Then we've got our exponential, or our geometric sequence, is a sub n equals a sub 1 times the common ratio raised to the n minus 1 power. We always use n minus 1 when we're working with our sequences because we already took into account the first term, so we don't have to worry about, so we always take 1 away from the term number that we're looking for. And then we've got y equals a times b to the x for our exponentials. We could also include in there, and I didn't, exponential growth and exponential decay, right? Y equals a times 1 plus or minus the rate as a decimal raised to the exponent. So what we need to consider, or continue to consider, is that when we're looking at a graph of a linear, we are seeing constant rate of change, okay? So our slope is constant throughout. And what you should have noticed if you tried that worksheet or that assignment that I gave you the other day, what you should have noticed is linears often start out higher than our exponentials, but eventually what happens is our exponential overcomes that linear. And the questions that were asked on that worksheet were basically, when does, not necessarily the point of intersection, but when does that orange line, that exponential, exceed the linear? Okay, because eventually it exceeds that linear. It's going to surpass that linear. So what you need to make sure you know how to do is determine the difference between linear and exponential. So I have written here 2 examples, and we're going to look at the top one first. A library has 8,000 books and is adding 500 books each year. So if it starts with 8,000 and we're adding 500 each year, this is a linear growth. This is a straight up constant rate of change, 500 each year, okay? So this guy would be considered linear. Down here where we have a bank account starting with $10, every month the amount triples, okay? Now you're looking at multiplication. This is a geometric or an exponential growth, okay? If you're multiplying, if you're doubling, if you're cutting in half, if you are changing by a certain percent every year, that is an example of exponential, okay? So I'm going to do one example from our problem set that we had assigned yesterday. Hopefully, if you didn't do well on it, I said if you only got 1 right or fewer than 1 right, you need to redo it. So I'm going to go over the one with turkeys and deer. So, yeah, turkeys and deer. I believe it was like some woman with an S. Sheila is a wildlife biologist, and she is counting the number of deer and turkey in her rescue, okay, in her reserve. So, Connor, you didn't finish reading, by the way. She starts out with 12 turkey in her first year, and then we saw that the number increased by 40% each year. So her turkeys started with 12 and increased by 40% each year. Ding, 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 right? You're seeing percentage. This has to be geometric, okay? So we are looking at an exponential here. You can put that down, please. Thank you. Okay, so that's exponential. Now your white-tailed deer population, okay, our deer population started with 18 deer, and this was increasing by 10 deer per year. Okay, that's your rate. So this automatically is now linear. We're adding 10 each year. Now, is this really happening? No, but this is our example. So this guy is going to be
he's very good at English
linear.
and social studies.
Okay, so now we've got to create our equations. So I'm going to keep this one in pink. we've got our turkey population started with 12, right? That's our initial amount. 40%, you should right now be saying, Miss Pierce, change it, right? We need to change this to 0.40. We have to move that decimal spot over twice so that we can represent our percent as a decimal. Now, because we're experiencing growth, we need to add 1 plus 0.40 or 1 plus 0.4. Okay, this is growth, so we have a 1 plus inside of our set of parentheses here as our base. And then our exponent is n minus 1. Okay? For our deer population, we start at the end of the first year, the beginning of the first year with 18 deer. Turn that off, please.
Alexa, turn on.
Plus n minus 1. Why is that? Term, take 1 away because I already included the first term, right? Times the common difference. In this case, the common difference is 10. We're adding 10 each time. If we were taking 10 away, it'd be negative 10, okay? Now, this is connected to our set of parentheses here, this n minus 1 quantity, through multiplication. You could also write it, and I actually prefer to write it, as 18 plus 10 times n minus 1. I prefer to do that because we are often familiar with seeing our distribution on the left-hand side of that parenthesis. The question is asking, what year is the first year that we see our turkey population exceeding our deer population? So if you take out your calculator, okay, I'm going to type into my y equals, oh, and I have it in here already. How convenient. I have in here already. Notice how I put y1 equals 12 times 1.4 to the x minus 1. And then for my y2, I put 18 plus 10 times x minus 1. Okay? When I hit graph, which, isn't really necessary right now, I don't need that negative portion of my x's. Really, all I'm focusing on is my quadrant 1 because we're dealing with time here. But that's not what you want to look at right now. What you want to look at is your table. So I hit second graph, and now I can take a look at my table. Okay? Y1 represented my turkey population, and Y2 represented my deer population. And I am looking for, so there's year 1 had 12 and 18. Year 2 had 16.8 and 28. I am looking for the first time that I see my Y1 column greater than my Y2 column. And if you look here, at year 7, I've got 90 turkey and 78 deer. So year 7 is going to be my answer here, okay? So when I type that in, I can put in what year is Sheila going to count more turkey than deer? Well, Sheila's going to count more turkey than deer in year 7, okay? Hopefully this helps you. Every other problem follows similarly, where you have to set up your equations for both your linear and your exponential. Pay very close attention to which one is which. If you see something growing by just some number per minute or month or year, then that's your arithmetic sequence. And when it's multiplying or growing by a percentage, that's your exponential. Good luck. We have class tomorrow at 1 o'clock. See you then. Bye.
See you then. Bye.